So chapter 10, we're going to talk about preparing a budget, and in this one there are only 4 sections. So we're going to do utility expenses, electronic utilities, charting a budget, and cash flow and budgeting. So we're going to start with 10-1, which are utility expenses. We're going to compute the cost of electric, gas, oil, and water for the home, compute the cost of using specific appliances for specific lengths of time, and compute the time it takes an energy-saving appliance to pay for itself. Our key terms, we have utility. This is your expenses for electricity, natural gas, oil, and water that are incurred while living in a home. A meter, this is not the measurement, but this is an actual meter that's on the side of your house that tells you how much of a particular utility you've used. Watt, this is a unit of measure used for electricity. A watt hour is used for electricity, so 60 watt bulb for 2 hours uses 120 watt hours. Kilowatt hour, this is how they measure electricity when they sell it. It is equivalent to 1,000 watt hours. So a kilowatt hour is equivalent to 1,000 watt hours. Cubic foot, this again is a unit of measure by which natural gas and water are sold. It represents the amount of space occupied, not the weight. CCF, this is a unit of measure that represents 1 cubic feet. Volume, this is the amount of space inside of a 3D region or 3-dimensional region. It's measured in cubic units. Previous reading, this is when they take a reading of your meter. It was the last time that the meter was read. And then the present reading, this is the current meter reading. So how much will it cost to run the utilities in your home? Name some ways that you use energy in your daily life. And then, do you pay for the energy used in your home before or after it's consumed? So you need to go ahead and finish this in your notes as well as on a separate sheet of paper to be turned in. And we get into our examples. So example 1, Tom's October water bill listed 2 meter readings. The previous reading was 3,128 CCF, and the present reading is 3,141 CCF. How much water did Tom's household use during the billing period? So in order to calculate this, we take the present reading minus the previous reading. So there's your present reading of 3,141 CCF, and your previous reading was 3,128. So you need to go ahead and subtract those and tell me how many CCFs he's used in this current billing period. So please finish this question. Check your understanding. We're going to go ahead and skip this question and go on to example 2. Janet works for a utility company and is reading the Civit's household electric meter. What is the reading? So a lot of them now are going digital. They used to have these dials, and some of them, if you go and check your house, you might actually still have this unless the electric company has come in and upgraded you. But this is the meter, and here's how you read it. So we take a look at each of those arrows, and we take the arrow closest to the smaller of the 2 numbers. However, if the arrow points between 0 and 9, we read it as 9. So this first arrow is between 1 and 0, so that becomes a 0. The second one is between 9 and 0, so we read it as 9. The third one is between 5 and 6, so we read that as 5. The other one is also between 5 and 6, so we read that as 5 as well. And the other one is between the 1 and the 2, so that's read as a 1. So basically, we round down unless the arrow is between 0 and 9, and then you round up. Okay, so this meter reading is 9,551 kilowatts per hour. Okay, check your understanding. What is the CCF reading indicated by the dials? So you need to actually go ahead and finish this in your notes as well as on a separate sheet of paper. So where those arrows are between those 2 numbers, what is the number that should be there? On to example 3. A certain electric mixer requires 125 watts. How much would it cost to run the mixer for a total of 90 minutes at a cost of 10 cents per kilowatt hour? So the first thing we need to do is convert 90 minutes to hours. So we know there's 60 minutes in an hour, so we take 90 divided by 60, and I get 1.5 hours. Then we need to find the watt hours. So we take the 125 watts that it takes to run that electric mixer and multiply it by the time that we're going to run it for, which is an hour and a half or 1.5 hours. Multiply those 2 values, and you end up with 187.5 watt hours. To find the kilowatt hours, we take the watt hours and convert that into kilowatts, so we have to divide it by 1,000, because remember there's 1,000 watt hours in a kilowatt. So when I divide, I end up with 0.1875 kilowatts per hour. To find the cost in kilowatts per hour, we take the 10 cents and multiply it by the kilowatt hours. So 0.1875 times 0.10 equals 0.01875. So it's roughly 1.9 cents to run this. So it's between 1 and 2 cents to run this electric mixer. So again, we have to convert the minutes to hours, find the watt hours, find the kilowatt hours, and then find the cost per kilowatt hour. Check your understanding. We're going to go ahead and skip this question, so all of these should have skip across your page. Example 4, depending on the climate, utility usage can vary according to the seasons. Electric bills can be higher in the summer due to air conditioning use, and gas and oil usage can be higher in the winter due to heating needs. For this reason, some utility companies offer balanced billing. This evens out the monthly cost of utilities to make the homeowner's payments predictable. Last year, the Ross family spent $3,336 on electricity. They are opting to use balanced billing for next year. What will their monthly payment be? Well, to do balanced billing, they take the last year's electric usage in cost, so which was $3,336, and they break it up over a course of a year. There are 12 months in a year. So to do this, you need to divide the annual cost by 12 to get the monthly cost for this year. And then if there's any difference, they'll add that or decrease that from your next year's billing cycle. So you need to take this 3,336, divide that by 12 to get what they pay per month this year for their billing. So go ahead and finish this question in your notes, please. Check your understanding. We're going to go ahead and skip this question and go on to example 5. Energy savings often pay for themselves. So, those Energy Star appliances, they will eventually over time pay for themselves. This means that the savings in energy usage can equal or offset the cost of the item after a certain number of years. The Thompson's old water heater cost them $455 per year to run. The new one they purchased for $1,240 will save them 31% annually in energy costs to run it. In how many years will it pay for itself? So the first thing we need to do is compute the savings per year by finding 31% of 455. So 31%, we need to make that into a decimal, so it's 0.31. Of means multiply. So we find the percentage there, which is $141.05 that they save per year. So you're going to take and divide the cost of the new appliance by the annual savings in energy. So we take the new cost of the appliance, which is $1,240, and divide that by what we're saving by having this new one, which is $141.05. And we end up with approximately 8.791 years. So what does that mean? Well, the water heater will pay for itself in about 9 years, since it will take more than 8 years to save more than $1,240. So just over 8 years, we're going to say about 9 years, we'll have saved, because we bought the new one, we'll have saved the amount that it cost us to buy that new one. So that's how it pays for itself over time. So the more efficient, the quicker you'll actually make that money back, essentially. Check your understanding. We're going to go ahead and skip this question. And that is the end of 10-1.